So go ahead and read and take notes on this screen. A couple things I want to point out is that down here where you have 2 is less than 4, you can add the same amount to each side of the inequality and still maintain that inequality to be true. So in this case they have 2 plus 3 is 5. And then over on the other side we added 3 to 4, and 4 plus 3 is 7. Well, 5 is still less than 7, so that inequality is true even though you're adding 3 to both sides. The same thing occurs when you subtract the same amount from each side also. If 6 is greater than 3, then 6 minus 4 is 2, and 3 minus 4 is a negative 1. 2 is greater than negative 1, just like 6 is greater than 3. This also works for anything with the greater than or equal sign or the less than or equal sign. So how are these properties similar to the properties of equality? Well, essentially they are the same because they maintain a true statement of inequality even though you're doing the same thing to both sides of the equation. Okay, so let's take a look at solving an inequality using subtraction, or in the case that I've mentioned in class, we add the opposite. So in this case, they're showing it as in the same line. So if we're adding 3, then the opposite is to subtract 3. I went ahead and rewrote it over here as x plus 3 is greater than 10. We take 3 away from both sides, and we're left with x is greater than 7. Now the thing is, when you solve this, we don't have to pick 7. Actually, we can't pick 7. We have to pick a number that is greater than 7. So in this case, they picked 8. We could pick 10, we could pick 12, we can pick 100. It doesn't matter as long as the number is greater than 7. They plug in 8, and 8 plus 3 is 11. They add this question mark here to say that we don't know if it's a true statement or not. But when we do simplify so that both sides have one value, we notice that 11 is greater than 10, and that is a true statement. All right, so let's take a look at using addition. They have it written over here as adding 5 to both sides, but I've gone over here, and just like we've been practicing our process, I use definition of subtraction to do n plus a negative 5, and then we're adding 5 to both sides to cancel out that negative. So we're left with negative 1 is greater than or equal to n. But notice if we want to change it around, let's say we don't want to say that the value is being compared to the unknown, we want to say the unknown is being compared to the value. Notice what happens. If you're going to move these around, you have got to flip the direction of the inequality. So instead of negative 1 is greater than or equal to n, we can say n is less than or equal to a negative 1. And they're making that statement here on this side too. And then to go ahead and do our check, negative 6 is greater than or equal to n minus 5. I need to pick a number that is less than negative 1. So I chose negative 10. Again, you can pick any number that is less than negative 1. So negative 10 plus a negative 5, which I've rewritten here, is negative 15. And when you compare it to the value on the other side, negative 6 is greater than or equal to negative 15. That is a true statement. All right, so here are 2 more equations for you to try on your own. Please refer back to your notes on the examples we just did, and then continue this video, and the next slide will be the solutions. Okay, so here are our solutions, or this is what you should have. Writing this in a vertical format, we add a negative 8 instead of subtracting 8. So that means I'm going to add 8 to both sides, and you should have ended up with negative 13 is greater than or equal to d. So now turning it around so that d is being talked about first, d is less than or equal to negative 13. The reason why you want to do that also is it makes a little bit more sense to pick a number that is less than negative 13. So when I do my check, I like to pick powers of 10 or 0 or 1. Obviously I can't use 0 or 1 because they're not less than negative 13, so I pick negative 20. And when I plug it in, negative 20 plus negative 8 gives me negative 28, and negative 21 is indeed greater than or equal to negative 28. All right, this one asks you to graph it on a number line. So I went ahead and did the work. H is less than 6.5. So I need to pick a number that is less than 6.5. And like I said, I like to use 0 when I can because it just makes it simpler. So instead of H, I put 0. 0 minus 1.5 is less than 5, and negative 1.5 is indeed less than 5. So to graph this, since we have done graphing, you can do an open circle, and then what you do is you graph everything to the left. So anything that is less than anything less than 6.5. All right, and here's another example of graphing. So you can write this down and study it, and they explain the exact same thing that we just did on the previous slide. The concept check, does an inequality have only one solution? Well, if you look at the graph, you'll notice that the open point means that we can't use 1.5, but we have all these other solutions that we could use. So the answer is yes, we do have more than one solution. Okay, so here's how it is applied in a word problem. Antonio has $18 to ride go-karts and play games at the state fair. If the go-karts cost $5.50, what is the most he can spend on the games? So as you're doing your plan, the thing you need to pay attention to is at most. And remember, at most means less than or equal to. So when you're setting up your equation, $5.50 plus the cost of the games is less than or equal to $18. So when they solve it, they drop the 0, and they end up with x is less than or equal to 12.5, which is $12.50. So if you wanted to check this, what they did was they picked $10 to use, and when they plugged it in, they got $15.50 is less than 18, which is a true statement. Okay, so try it with Katya. Has $12 to take to the bowling alley. If the shoe rental costs $3.75, what is the most she can spend on games and snacks? Once you've done this, go ahead and continue the video, and we will do the solution. Okay, so the solution to this would be $3.75 plus x, and if she has, what is the most that she can do, that means is less than or equal to $12. So if I subtract $3.75 from both sides, I'm going to go ahead and put the dollars back in here. What I end up with is x is less than or equal to, this would be 25, and 11 minus 3 is 8. So she can play $8.25 worth of games, and that would make sense. If I want to pick a number less than $8.25, I can pick like 8. So when I plug this back in, $3.75 plus x is less than or equal to $12. And I'm going to use 8 as my number less than $8.25. Well, 3 and 8 is 11, so 11.75 is definitely less than $12. So that's a reasonable answer. Okay, here are the sample problems for you to do, and once you're done with these, go ahead and continue the video so you can see the answers. And here are the answers. Make sure you write down any questions you have and bring them into class to discuss. All right, see you later.